Hi, good morning, good afternoon, good evening, everyone. My name is Stephen Simon, and welcome back to CSharpCorner live show once again. Uh, for this episode, we're going to talk about the current and future state of voice technology. Joining us will be Sanjeev and John, all the way from United States. We all have Alexa and Google Assistants with us. Uh, and this talk is very different as we're going to have a bunch of demos and a pure go through of the application that if you want to start with voice technology and understand how this field is going during this pandemic. So without wasting a time, I would like to pull in Sanjeev and John, our guests for today. Hi, John and Sanjeev. How are you doing?
We're
Hey,
doing good.
Simon. Good.
Yeah, we're doing good.
Uh,
So why
per-
don't I take it? I'm Sanjeev Surati. I'm one of the co-founders of our startup Whetstone Technologies. I'm an ex-Microsoft guy. I've been in the software industry for about 25 plus years. When I was at Microsoft, I worked on the Windows product team and for Microsoft Consulting Services. And since this is primarily a developer audience, my current coding stack is C#, .NET Core, and AWS.
Oh well, that matches with our community name, right?
Yep. And I'm John Iwasz. I'm the Sanjiv's co-founder of Whetstone Technologies, and I also have a similar background. I spent 12 years at Microsoft in Microsoft Consulting Services, traveling around the country, delivering solutions for clients. And now we're focused on delivering voice solutions. And we're using the stack Sanj had mentioned, C#, .NET Core, AWS, all built on a serverless architecture.
That's great. That's great. We have some very senior guys joining us today. Why don't any one of you just go ahead and give us an idea on what exactly we are going to talk today before we move into the slides?
Sure. So the way we've kind of broken the presentation up, give you an idea of what the adoption rates, just what people are seeing, what are the consumer, what does this all mean? Because it's not just smart speakers. There's so much more involved in voice technology. We'll give a demo of a voice application that we have put together that's running on that architecture John just mentioned. And then we'll give an overview of what a voice application is, some of the different challenges, what it takes to write these voice applications. And then we're also going to talk about some potential future state of voice technology, and then we'll open it up for questions.
That's really sound interesting. One note to all the viewers who are watching us right now, it may be on YouTube, Facebook, Twitter, or Twitch. You guys can drop your questions in the live comment section below, and John and Sanjeev will be answering your questions in the live episode just after they complete this slide, and maybe even during the live show. So if you have any query to whatever they're presenting, and if you want any guidance for your career moving into voice technology, you can just drop comments below and our speakers will be answering in the live show. Having said that, I'll leave you and John. The live show is all yours now. Okay, I'm gonna pull up your slides, and there you go.
All right. So let's start with voice technology. These days, when people think about voice technology, they either think of Alexa or Google Assistant. And those two technologies, those are assistants. They are voice assistants. And that's what's driving smart speakers, which overall have seen the fastest consumer adoption of technology ever. And that includes cell phones. As of January of this year, 1/3 of the adult populations in the United States has installed smart speakers in their homes. Now, when you think about smart speakers, please note that the numbers the technology in these numbers does not include cell phones or other devices with voice assistants built in, such as TVs or cars. Google Assistant is native to Android phones. And in 2019 at CES, they announced that it was available on over 1 billion devices worldwide. This year, Google announced that they have 500 million active users per month spread over 90 countries on Google Assistant. One of the other interesting announcements they made is that they're also planning to replace voice search in Chrome with Google Assistant this year. So, when you start thinking about voice technology, don't just think Amazon Echo, Google Home. You need to think about the other devices in that. So now that I've kind of explained, what your possible target audience can be, what could you do with a voice application? So for that, I'm going to give you a short demo here. And this is running live on my Echo Show. Echo, open Whetstone Technologies.
Welcome back to Whetstone Technologies. Would you like to learn about SonaBridge or hear more about Whetstone Technologies?
SonaBridge.
SonaBridge is our patent-pending cloud-based platform that enables brands to monetize Amazon Alexa and Google Assistant voice apps. We integrate voice apps with text messaging to deliver offers immediately upon user opt-in. Use cases include product purchase incentives, travel and tourism discounts, and offers for professional services. Want to receive an offer code for a free 1-hour voice tech consultation and a free white paper about voice technology?
Sure.
Great. I'll need you to provide a 10-digit mobile phone number so I can send you a text message from Whetstone Technologies using SonaBridge.
It's 610-299-1571.
I heard you say 610-299-1571. If this is correct and you agree to receive a text message from Whetstone Technologies using an automatic telephone dialing system, say yes. Message and data rates may apply.
Yes.
Thank you. I'll send you a text message shortly. Please note that consent to receive text messages is not a condition of purchase. Goodbye.
So what we showed there with that demo is we start with one ubiquitous device, which is a smart speaker. That was my Echo Show. And then it transitions seamlessly to another ubiquitous device, which is my cell phone. And actually, for some reason, my cell phone didn't ding, but I just got the message delivered on my phone. And the thing is what you can do with this technology. It's not just you don't just think it's something you talk to. The way to approach a voice application is, what can you do to make other things happen? And that, whether you're turning on lights, whether you're starting your Xbox, there's, what can you do to leverage, to leverage and act as another mode in interacting with other types of technology. So just to give you a note, that particular application, that was running on Alexa. That's called an Alexa skill. That is available and running live right now. It's currently in the United States only, just because this one is working with text messaging. And now to just give you an idea of how voice applications work and some of what it takes to develop them, I'm going to turn everything over to John.
So what you just saw was a demonstration of Alexa's skill. We generally use the term voice application to mean the broader umbrella of voice experiences. Alexa calls them skills, Google calls them actions, Samsung Bixby calls them capsules, but whatever you call them, they are voice applications and follow a similar model of natural language. They follow a natural language model that you must configure before any of these applications go live. That NLP, or rather NLM, is comprised of the invocation name. You just heard Sanj use Whetstone Technologies to open the skill. It's the unique identifier that can be used to invoke one of these voice applications on a smart speaker. There's a number of design considerations that goes into selecting what that invocation name is. You want it to be unique, relatively easy to pronounce. You can be mindful of brand names. For example, if you have a brand name that's a little hard to pronounce for a business, you may want to shy away from using that. Use something a little bit more ubiquitous. Once the voice application is launched, it's a question-answer scenario. You invoke the voice application, it gives you a brief introduction, and then prompts you with what you can do next. The next statement you make is an intent. That's effectively a voice command. You've heard Sanj say yes when asked if he wanted to receive a white paper from Whetstone Technologies. That yes rolls up to a yes intent that your voice application processes. Other commands could include no, book a flight, book a hotel. Usually these intents are, they can be expressed multiple ways. You can say yes, you can say yeah, you can say okay. Each of those different phrases is an utterance that rolls up to an intent. So as a skill developer, as a voice application developer, the inbound command that you get from the user's input into the device is, okay, they asked for a yes intent, but you don't necessarily know exactly what they said. They could have said, sure, okay, go ahead. None of that, you generally don't get that fine-grained information in the inbound request. But the intent by itself is not sufficient to complete the user experience. You heard Sanj provide a phone number. That phone number is provided by a slot, which is essentially a variable. So you would have a phone number intent. The utterance would be something like, my phone number is, my number is, and what follows would be your spoken phone number that would come into your voice application as a slot, as a variable. Slots can have synonyms. In the book a flight scenario, you could say what city you're going to, right? I'm traveling to, Philadelphia. Well, I happen to be based out of Philadelphia. And it's common for people in the Northeast and across the US to refer to Philadelphia as Philly. So you may have a synonym attached to the slot variable destination, and the person may say Philly or Philadelphia, but you'll receive Philadelphia as the voice application developer. When you do decide to lay out your natural language model, it's important to consider the flow of the application. Whenever you write a user interface, it's common for developers to start with wireframes. It's usually the user experience that's discussed and ironed out before the first line of code is written. The same holds when you're designing a voice application. You really should lay out a script and a scripted experience which will inform what intents you need, what prompts you need. And it's helpful when you're designing this experience to sit down with somebody that is unfamiliar with what you're trying to do and act out that script with them to see if the prompts that you use elicits the responses that you expect and the intents you expect. That design practice is called voice UX. We're generally familiar with user experience design and UX. This is voice UX, VUX. If you search for it online, I'm sure you'll find it. It may also be referred to as voice user interface, VUI. So again, one of the first things you should do before you write your voice application is script it out. That'll inform your natural language model, and work with somebody to test out that script. So now we're onto the response side of the house. So when Alexa gets a request, Alexa sends a response. The way those responses are sent is either plain text, but that could be read kind of flatly. Alexa, you want to give Alexa some personality that makes your skill stand out. So one way to do that is to return an SSML response. That's speech synthesis markup language. Say that 10 times fast. It's a format of XML, and it's an open standard. And with most open standards, you'll find that different platforms have slightly different implementations of it. So find on Alexa is different than what you'll find on Google in terms of the different tags that SSML is supposed to support. And some platforms have custom tags that they've added. There is an effort to normalize this, which is called speech markup. I suggest you Google that if you're interested in learning more about SSML. It's attempts to normalize the expression of SSML across multiple platforms. So in these three examples, they'll show you how you can change the speed of the return speech using prosody. So Sanj, if you will.
An eagle's win would have been noise.
Yep,
I can speak with my normal pitch, but also with a much higher pitch and faster, and also with a lower pitch and slowly.
Right. So you just saw how you can manipulate Alexa's voice. This becomes handy when you're talking, when you're considering accessibility scenarios, where if you're designing a skill for somebody that may be a bit hard of hearing, you can increase the volume or decrease the rate of speech. So again, consider your target audience when you're putting your SSML responses together. You can also override the pronunciation of various words. Again, with brand names, or last names, you'll find that the smart speakers generally don't pronounce them quite right. Well, you can modify that. And again, since I am out of Philadelphia, our local football team is called the Philadelphia Eagles. But the local Philadelphia accent is a bit odd. So sometimes you might hear somebody refer to Eagles as Eagles. And so I wanted to design an experience that was a little more closer to how Philadelphians speak. And so you can hear this example.
An eagle's win would have been noise.
Do that one more time. That went by fairly quickly.
An eagle's win would have been noise.
Right. So you, rather than eagles, you heard eagles. And the word nice is sometimes pronounced noise with that long O. And then finally, you can have relatively short audio files embedded in your response. That's useful if you're creating a game, or if you want to create a branded experience with a jingle, or sometimes it's referred to as sonic branding when you want to associate a sound with a particular brand or business. So Sanj, if you will.
There's a troll in your way.
Right, so this has two interesting examples of embedding the MP3 and also changing the voice that is coming back. Alexa supports Amazon Polly, which includes a few dozen different voices that are designed for different dialects. Emma happens to be a UK-based voice. And this voice name tag that you see there is specific to Amazon. You wouldn't be able to go to, say, Google a Google action and use this same tag. It's very closely tied to Amazon. So let's say you wanted to create an Alexa skill. There's a developer console, developer.amazon.com, which lets you stand up an Alexa skill, define your natural language model, and wire it to a backend. That backend could be supported by a serverless Lambda function. If you're familiar with Azure, it's Amazon's answer to Azure functions. Or you can have it go to a REST endpoint, which you can host, of course, in your cloud provider of choice or on-prem. At that point, of course, it doesn't matter. It's your decision where you wish to place it. The smart speaker call is made to Amazon hosted services in AWS, and then an Alexa request, that's a JSON message that contains the intent, slot values, user identifier, is all sent to your REST API or Lambda, and you return an Alexa response. And your Amazon Developer Console is used to create kind of a developer instance where you can test it locally. There is a test harness you can use before it goes live, and that's where you can determine and wire up a REST endpoint or a Lambda endpoint. So move on to the Google Actions. So there are some similarities here. Just as you have the Alexa Developer Console, you have a Google Actions console where you'll create your Google action as well as the metadata that goes around the Google action, like the invocation name, when you publish either a skill or Google action. There's a description text you can set. There's an icon that you associate with these skills and actions that shows up in the action console. And just as you can configure a Lambda or REST endpoint in an Alexa skill, you could use a Google Cloud function or a REST endpoint. And there's a little bit of a difference between how the NLP model is defined in this user experience, in this developer experience, versus how it's defined in Alexa. The Action Console is a different interface than the Dialogflow console. So you define your NLP model or NLM model in Dialogflow, and you define your action metadata, and you run your test harness in the Action Console. It takes a bit of getting used to. And there is an important distinction between Google Actions and your Alexa skill. Google gives you a little bit more information on the inbound request, on the Dialogflow request that's coming into your skill. It includes what the Google device thinks it heard the person say. So on Alexa, if somebody said, yes, yeah, okay, sure, go ahead for a yes intent, the only thing you'll see as a developer is the yes intent inbound on the request. With Google Actions, you get a little more information. You get what Google thinks the person said. So you'll get the yes intent, but you'll also get the speech-to-text transcript of what the person said. That's incredibly useful if you have something that the person said that doesn't map to an intent that you had already defined. Let's say you expected the person to say yes, no, but they said maybe, and you didn't account for that. On Alexa, you would get a fallback intent, and that's all. So you wouldn't get what the person said. On Google, you would get the equivalent of a fallback intent, but you will also get what the person said. So you'll get that maybe, and you can use that to inform updates to your natural language model. So you're probably not going to get it right the very first time you publish your Google Action or Alexa skill. I would suggest that you publish on both platforms because what you get on Google is probably a similar experience that people are having on Alexa, but you can use the recorded speech that Google gives you, the recorded utterance that Google gives you, that'll help inform how you change your natural language model. And as from a back-end standpoint, Alexa will send you two requests. Well, it'll send you an initial request, and then if your REST API or your Lambda does not respond within a couple of seconds, it'll send you a second request. And it'll expect you to respond within 8 seconds. And if it doesn't, then the skill abends and the user is removed from your skill. Google Action will send you one and only one request and expect a 6-second SLA response time. It'll also send a health check request coming in. And that'll come in about every 10 minutes. It's like a ping request to make sure that your endpoint is still responsive. We found that Google's documentation is not quite as crystal clear as Amazon's documentation is. So if you are looking to publish a Google Action, make sure you search the documentation for a health check, because we had an experience when the first time we published a Google Action, we missed the documentation on the health check, and the skill went live. The Google Action went live surprisingly, without the health check being monitored and being responded to. And then within 10 minutes of it going live, we started getting notifications from Google saying your action is non-responsive, it's about to be taken down. And it took us going through some logs to find out exactly what was going on. So don't miss that nuance. We were very surprised that we were able to put a Google Action into production without the health check in place.
Okay, and I'm going to close out one last voice assistant, which is Samsung's Bixby. That one's relatively new, having come out. Really, Samsung really started pushing what they call Bixby 2.0 sometime around summer to fall of last year. With Samsung's Bixby, what you end up developing is what's called a Bixby capsule. And Bixby 2.0 is available on Samsung smartphones and TVs, and eventually it's going to be coming to appliances. Now, Samsung's taken a very opinionated approach that's very different from what Google and Amazon did. In order to create a Bixby capsule, you must use Bixby Studio, which is a completely integrated development environment. When you create a capsule, what they do is they follow an MVC pattern. So they just renamed it slightly. So what you do is you create what they call concepts. That's effectively your model. Views are called views, and actions are essentially your controllers. One of the things about Samsung is because they started with the phone, instead of Echo or Google Assistant, where there isn't necessarily a screen device, they go off the assumption that you've got a screen in front of you somewhere. So they really work with you to want you to create multimedia experiences that are also voice driven, which again is somewhat different, but it does make for some pretty cool stuff, because you end up having to spend a lot of time putting that together in the studio. Now, when you define actions, they can be defined as either local or remote. If they're local, they're essentially just little chunks of JavaScript that get shipped with your capsule and end up being hosted by Samsung. If they're remote, then each of those actions is an individual REST API call. With Google and Google Assistant and Alexa, you have a single endpoint that gets a message that you work with. In the case of a Bixby capsule, each one of your actions has to have its own endpoint. So, that's just something else to consider. And one of the other things that comes with this model is that when you publish the capsule, everything gets pushed and hosted up in Samsung's cloud. But because everything is so tightly bound, any sort of a change, even if it's a minor one, like just updating an image and things like, or changing a response, you pretty much end up having to republish the entire capsule. With Google and Alexa, as long as you're not making any significant changes to the natural language model, you can actually make changes to responses and things like that without having to do an entirely new publish. So on that note, I'm going to switch over to talking about future. I did see somebody asked about voice SEO. So what I'd like to do is start by talking about search and discoverability. The reality is right now on these devices, there's just really no good story. One of the challenges and that has happened with the way that this is sort of sprung up is that this has kind of grown organically. You had, Apple started with Siri, you have Alexa with Amazon, you have Google Assistant, you've got all of these are walled gardens. Everybody's doing things differently, and if you want something to work on all three of these different devices, you end up having to do different implementations. It's and one of the things with search and discoverability is they all do it differently. So, for example, with Alexa and Google, they actually had earlier, about a year ago, they were really, even with Amazon, I think it was about 2 years ago, they had the notion of something that they called a can fulfill intent request, which was something where you could say, I support this interface, and if Alexa thought that a question might apply to your skill, then it would call you and say, hey, can you answer this? And that was an idea. It's never left beta. It's still available, but I've never actually seen it work. And then with Google Assistant, they had the notion of indirect invocation, which is similar to the can fulfill intent request, where you could specify here's a bunch of phrases that if you get asked, I know what to do with. That seemed to be a direction they were going down about a year ago, but then both the platforms seem to have stepped away from it. As regards the voice SEO question, what Google has done is, and there's plenty of resources on the internet now. I mean, if you look up Google Assistant and SEO, they have gone down this path of looking for structured content in websites that can be used to inform search, Google's search, what to do if it's being accessed through a voice assistant. And that seems like a reasonable strategy. The downside to that is that it's not like a Google action. It's not really interactive. So you get something there. So I don't know what the story is yet. I don't think Google knows what the story is yet of how actions are going to fit into this. And I think you'll see the same thing with Amazon. I haven't heard much about what they do as far as structured content. I do know that they've been going down this path of Alexa Answers, where they're crowdsourcing content. A lot of times when they search, they end up hitting Wikipedia to try to get answers, but that's suboptimal. So they've been going through a crowdsourcing model on that. But that's kind of where this is. This is emerging technology, so a lot of this is literally being figured out, is still being figured out. All right. Next up, there's the notion of seamless integrations. I mean, the current reliance on invocation names for a voice application is kind of clunky. And one of the things we've seen, and we can see this actually from interactions that, John talked about on how Google, we actually see what people have said. So we've seen how people have interacted with some of the applications we've done. And it becomes really clear that people don't necessarily know that they're in a voice application, that you've actually transferred control from the assistant to the application. So some people some applications will work around that by this is one of the reasons people change voices or use MP3 files, because it does make it more clear you're within the world of an application. But a lot of users don't get that. I think as we start going forwards, the delineation between the assistant and an application will eventually start to blur, where applications may be more hints to the assistant. But that's something I think that is eventually going to play out. Again, we're dealing with emerging technology, so some of this is still being defined. And John, why don't I'll turn it over to you now for the last two.
Sure. So before I do dive into those, I do see a question on when can we have an assistant fast enough to reply to our commands instantly? Some of the technology, voice technology, depends on servers. It's not fast enough. So that speaks to an OEM embedded model, where the assistant is embedded in a device that is local to the user. We have seen that we've gone to a number of conferences in voice technology and see some technology that's emerging in automobiles, right? It's trying to become a bit more commonplace to find integrated voice experiences in, Toyota, I believe, has their current year models include voice assistants. So you would be able to change your radio stations, for example, by voice. Mercedes had one of the conferences we went to had a Mercedes on display that would let us change, lights inside the car to different colors. It would let us change the AC settings. Interestingly enough, and this is just a footnote, but it wouldn't let us raise or lower the windows, interestingly enough, because you can't communicate how far you want the window to go up or down easily in a voice command. It doesn't sound natural to say, lower window 10% or 80%. The command would be, lower window, and the auto manufacturers are still working on the nuances of how to interpret some of those commands. Now, in some cases, the servers can be a little slow in starting up. So this goes back to the earlier design questions or design considerations around standing up a skill around a Lambda function. Sometimes you'll find a cold start with your Lambda function. And once it starts up, it's much more responsive, and the response rates from a warm Lambda or a warm, Azure function are nearly instantaneous. But the first hit to a cold function could incur a couple seconds of startup time. And there you want to minimize the number of resources that your serverless function depends on when it bootstraps. So rather than, say, going to a configuration store, you may want to embed the configuration into your deployed Lambda and reduce the number of resources that it depends on on startup. So with respect to touchless interfaces, moving back to the slide, of course, the current pandemic is on everybody's mind, and technologists that are involved in voice technology are considering and thinking about how to leverage voice technology to assist in reducing the spread of COVID-19. And this moves beyond the smart speaker experience. Of course, you can get COVID-19 updates on Alexa, on Google. The general rate of people interacting with smart speakers has gone up. More people are home, more people are trying them, and more people are engaging with them. They're we've certainly seen an uptick in the voice applications we've released, and that's not and we're certainly not that's not a unique situation. But I think we're going to see voice experiences move into other unexpected, at least in the US, unexpected devices. For example, in Japan, you can get into an elevator and you don't have to touch a button. You can tell it what floor to go to. And I anticipate that that technology will be coming to the US and other countries. Where you want to take some care is when you're considering what kiosks and public voice experiences to enable. Of course, you want to consider security. So voice enabling an ATM, for example, may only be available if that ATM is located in a booth and there's only one person expected to be in that booth, so you don't overhear, say, a PIN number or any sensitive financial data. So there's, of course, there's a concern about security in general with voice technology. You know, a common objection that the consumers have for not adopting smart speakers is that they don't want Alexa or Amazon or Google to hold on to their voice samples. And you know, the companies have been coming around and giving users privacy settings that enable you to not store your voice history. But there's been an organization that's emerging called the Open Voice Network that's attempting to bring a level of trust to smart speakers and voice UX experiences. So they're focusing on security. The best analogy I can think of for the Open Voice Network is they're becoming a W3C. They're two. Let me come up with the analogy. They're what HTTP and the web is to W3C is what Open Voice Network is targeting for voice applications and smart speakers. So that includes standardization around security, as well as creating one of the early mandates for the Open Voice Network is to create effectively a voice domain name service for invocation names, so that, for example, if you expect to talk to McDonald's on Alexa, you would use the same command, open McDonald's, and that would be the same command on Google and the same command on Bixby. So the state of voice technology today is a little bit like it was in the 90s with websites, where you didn't yet have search engines. If you wanted to look for a website, you would go to some kind of a website aggregator like Yahoo. This is before Google came along. So the Open Voice Network is trying to bring some consistency to the what's now the Wild West of voice applications.
Okay.
That's perfect. I think you guys covered a lot of content in the first half, maybe, right? You talked about Alexa, the difference between all these three, Bixby, Siri, and all. Also from the developer's perspective, the documentations that are available for all these platforms. A couple of questions that you did indeed pick some of the questions from the comments. A couple of questions that hits here is one question that says, what is the potential of jobs in voice tech as compared to normal tech like a web dev? Because we have seen this fancy JavaScript framework coming, and web development has taken a really new phase from 2017 and 18. And since this voice technology is very new now, how should one approach, and what would be the progress in this journey?
Yeah, I can start that one, Sanj. Feel free to chime in, because I do have a couple of thoughts on that. So what we've seen in voice technology from the conferences that we've gone to is, and I've alluded to it earlier, voice user experience design is a discipline that's been emerging out of the wild west of voice application development, and it's starting to bring a set of standards and practices, like just as you had UX, user experience design, has grown and evolved over the last decade. Voice UX and voice user experience design is starting to emerge as a dedicated discipline, and that includes designing for accessibility, designing for people that may be a bit hard of hearing. How do you design the experience for that? And of course, there's targeted specialized development in this space. So you've got your designers and you've got your voice experience developers. Sanj, do you have anything to add to that?
So no, the other thing I would definitely add, this is still emerging. So the number of people that are in here, it's still relatively small. So when people are looking for voice UX and developers, there's not a big pool of people to pick from. So, if you do get good at this and start putting yourself out there, there is quite a bit of opportunity. And, if you were at the beginning of the presentation, you can see the numbers, they do speak to somewhere you're going to see this stuff start to take off. It's not a question of if it's going to take off, it's when it does. I think an excellent place to start is that one of the things Amazon has done is they have an Alexa skill developer certification. So you can become, we actually have both been through that. And actually, John was about a year ago was involved in helping write some of the questions for the newer tests. So.
That's right. So if you do take the Amazon Alexa skill certification, you may get some of my questions.
Yeah, that really hard question. That's probably John.
That is well answered, John and Sanjeev. Adding to that, you guys both run a company out of this technology, right? And you did mention there are a bunch of documentation and there's some studios when you go and start developing for Bixby. One question that comes from the comments is there any open source library available for this voice technology? You said this field is very niche now. Not many people are into this. So have you come across any open source library all this time?
I can start that one, Sanj, and you can feel free to add. So there's sometimes there's a challenge if you want to create a voice experience for a platform that doesn't natively have an NLP engine. So I'll make that a little more concrete. So with Alexa and Google, right, they do the natural language processing for you. They do the translation of the of what the person says to doing speech to text transformation, and then map that text to an intent and slot values, etc. If you are developing a solution for an embedded device, then it's incumbent upon you to create that NLP model. So there is a Stanford engine coming out of Stanford University that's an open source model for doing localized, multilingual natural language processing. And they have a pretty reasonable licensing cost for that. And as Sanj is answering, I'm going to try and Google and see if I can remember what the exact name of that is.
And John, you can just give that link in the private, then we would send it to the guys watching, right?
Sure. And as for developing for across platforms for Alexa and Google at the same time, because they do use different their JSON messages are different. The Alexa request looks different from the Dialogflow request. Samsung Bixby's has its own model. So that's, we've intended to keep this presentation not be a sales pitch for our own engine, but at Whetstone Technologies we have written our own engine to deal with the translation, so that it's built on a level of abstraction. So plugging into another, currently we support Alexa and Google, and Bixby is on our roadmap. So we consider them just different clients that we can plug into our core engine. So in answer to that question, what libraries do we use for across multiple platforms? Well, we wrote our own.
And just to add on to what John was talking about, there is so I know with the I'm taking some conjecture here. The Stanford engine, there's an open assistant called Omit, which I believe is based off of the Stanford engine. And that's, again, a lot of this is all open source. And there was also at one point, and I think it's still out there, was a thing called Mycroft, Mycroft, and that's fully open source and that. But again, that's its own engine. John, didn't you write at one point, I think, isn't there a repository up on GitHub for, John disappeared.
Yeah, so George just, I think he's having some, maybe an
He must
internet
have had an
problem.
internet. Yeah.
He'll join us.
Yeah, I'm pretty sure, because John has actually written articles on doing, real basic articles on how to do, using .NET Core, how to create how to create an Alexa skill and how to create a Google action. And I think the source for that is actually up on GitHub.
Yeah. In fact, I do have an article that does show you using C# and Azure functions on how to support an Alexa skill and Google action, and that code in those articles is available in we have a public Whetstone GitHub repository, which is where you can see those code samples, and I'll also link those articles as Sanj is answering other questions.
Yep.
Okay, perfect. So moments back, Sanjeev, John mentioned about the slots, right? Would you like to go ahead and talk what are slots in Alexa and how you can use them?
Okay, so here's, I'll give you an example. That action, the Alexa skill I demonstrated, that is actually making some fairly heavy use of slots in that. So the way I think of slots is when you create an utterance, you can create a placeholder, which is effectively a variable that you can say is a slot. Now, when you define that slot, what you're really making is an enumeration. And that's like a bunch of values that work for that slot. For example, on both Alexa and Google Assistant, they have native slots that are built in that are like movie names or sports team names, things like that. So you'll see a slot that has the names of actors, things like that, or you'll even see a first name slot. And so what that is that's just basically, it's a giant enumeration, which is all the possible values that could be for that slot. And then what you do is you also define alternative ways to pronounce those names. So for example, for the Alexa skill I showed you for Whetstone Technologies, I've created an enumeration called Whetstone Names that has the name Whetstone Technologies and Sonabridge as two defined as two members of the enumeration. And then under Whetstone Technologies, I have multiple ways to specify Whetstone, which include, just Whetstone itself means Whetstone Technologies. It also says Whetstone. I noticed sometimes that the NLP would pick up Whatstone, W-H-A-T stone. So I went ahead and put that in there. With Sonabridge, I saw that often when it heard this, it didn't hear the term Sonabridge because this speaks to it's a brand name. It's a name we made up. So what it would actually hear is sauna, as in SAUNA space bridge. So I specified that as a synonym for sauna bridge, and that gets us. That actually that allows the virtual assistant, gives it some hints to say, oh yeah, he said sauna bridge. That's what I heard, but what he really meant was the one word sauna bridge. Does that answer your question?
Yep, that's perfect. That's perfect. One thing, Sanjeev, that you even in the beginning of the slides, you gave a demo for your Alexa skill,
Right.
right? So, is it possible? See, now I have a dot with me right now. Okay, I have a
Right.
dot with me. I'm in Asia now. So, how different is the experience a person would be of using an Alexa from Asia or for a Europe? Not just Alexa, it may be Bixby or Siri. How different is the experience and how much it changes?
So here's the short answer is the underlying application doesn't change so much, because what you're getting is intents and all of that. But what has to change for each one of those locales is the language model. For example, you're in Asia. I'm going to guess you're in India, and I'm just throwing that one out there. So if I wanted to make my application also work in Hindi, I'm going to have to define a language model for Hindi, right? I could still have a yes intent, but now it's going to have to recognize ha, right, as the that I said yes, or nay, that I said no. It's going to have to understand that. It wouldn't make sense in an English model, but in a Hindi model, it's going to have to do that. And then and then you also have, for example, different flavor. This always goes back to localization, because you not only have the language, but then you have culture. So, for example, with English, if you just look at Alexa, you have EN-US, you have EN-CA for Canada, EN-GB for Great Britain, EN-IN for India. And I will tell you, when I was doing some testing with one application we'd written for EN-IN, it will wait on the accent. So, being an American-born Desi myself, right? So you don't really hear an accent from me, but what I found was, like, so I'm used to saying stop, stop. I mean, that's how you say it in the US, right? But when I switched to EN-IN, it would not recognize that most of the time. When I started pronouncing it the way my parents would, with an Indian accent, stop, that it started picking that up. So the actual underlying language models do pay attention to accent and that. So and so the idea is when you create an application, if you want it to cross languages, you need to create a different model and publish for each one of those languages.
That's perfect. I think one question that follows along with your explanation is asked by Vedant. Vedant says, does it consider all the related word used in intent, or only those specific words that we may have defined during the development?
So it depends on the assistant. And, generally this is where AI comes in. You want to put as many utterances as you can. But the thing is that the AI behind the scenes, if you give enough hints, then the idea is and again, this is all going to vary from assistant to assistant, but generally what you're trying to give them is enough hints of these are the different things that get to this utterance, that the AI can then, if something sounds like it should fall into this, it'll then make the decision that this, so you theoretically don't need to specify everything, but it's right now it's generally a good idea to give it as many hints as possible, so that the AI can actually start to make some of the, like, I've had people say, oh, well, I've specified 2 or 3 utterances. Is that enough? No. You know,
You
I
got to
would,
train the model, right?
yeah, I mean, I would say for the phone number, intent for the Whetstone skill, there's at least 10 or 15 utterances that I specified just for that alone.
Yeah, and to add to that, getting numbers is reliable. So the assistants will hear, hear you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They'll understand that rather well. But spelling your name, spelling an email is not reliable. So I'll take my last name for example, Iwaszz. It's pronounced Iwasz. You can guess what the chances are that if I say Iwasz to Alexa, that I'll get the spelling correct. Right, and Sanjeev, it may or may not get that correct, even though that's a little bit more clearly pronounced. We did an experiment where we attempted to speak our own names as an intent with the letters as individual slot values to both Alexa and Google, and met with similar experiences on both platforms. The Z in my name came in as sometimes it heard B, sometimes it heard V. Sanja's name, when we spelled Sanjeev, it would skip the second E, 19 times out of 20. It did not hear the second E. So you may think that you can get around some of this by having the user spell the word, spell their email. That's not going to work. You do have a better chance at having the user speak a number ordinally. So if you say 1, 2, 3, you can you can get more reliably.
Yeah.
Having said that, yeah, Sanjeev.
Yeah, I was just gonna, I mean, again, that speaks to training. You have to have enough training in that model to get there. And having if you just have 26 letters, how does it, there's not enough training for it to recognize the difference between C and Z or D and T.
Yeah.
So again, that's a good example, I think, of why training and providing enough examples is important, because a lot of this is around pattern recognition.
Yep. One thing to note here, Sanjeev, is you might get some SMS and calls today because you just shared your contact number on the live show.
Yeah.
Right. So adding on to, I think we have reached 1 hour, but there are a couple of questions we would like to, before just wrap it up. One thing that I would like to ask is, what is the impact of IoT on voice technology on IoT? We see we can connect to appliances. There are the smart cities. There may be digital, projects coming. So how do we see voice technology moving into IoT, and what's next in this?
Yeah, so I can give I can tell you about my own experience with wiring up at home. Wi-Fi enabled lights like the Philips Hue lights have become rather popular, and at home, I have my Wi-Fi lights connected to my Alexa device, and so I can enable simple scenarios like turning the light on or off by voice, setting routines. So I can tell Alexa, I'm going to bed now, and it'll dim the lights downstairs. I can do a fun one, which is a great party trick, where I can say, Alexa, tell if this then that red alert, and you'll hear Alexa play, the Star Trek klaxons, like the ship is about to self-destruct, and my lights will flash red, and that drives my wife crazy, but I love it. You can also see IoT-enabled scenarios in business functions. So to make that a little more concrete, I have a friend who runs a business that distributes and configures equipment for performing intra vitro fertilization treatments for people that need a little bit of help getting pregnant. and the clinicians that operate the equipment often have their hands full. As you can imagine, the devices are very sensitive. And we have been in discussion in creating a voice-enabled scenario, which would be more of an OEM kind of delivery, where the clinician could ask for the microscope to zoom in or zoom out while their hands are occupied on other dials. I saw a question earlier about what applications this has to defense. I assume by defense you mean military applications, and you can apply that same kind of use case scenario where you have an individual whose hands are occupied, but they, ideally, if they could grow a third arm, they would. It's in those scenarios where having voice-enabled devices and IoT integration would make the job so much easier.
That's perfect. I think we'll take maybe this may be the second last that we take. Mahesh Beniwal goes in and praises that this is an amazing session you guys are having. What about the growth or market do you see for voice technology in coming years?
I think that really just speaks to, that's the question. Everybody, you keep thinking, okay, it's going to happen this year, it's going to blow up, because you have this situation where the consumer adoption is just ridiculous. We have officially moved past the early adopter, that stage. This is mainstream technology. So, from a consumer perspective, it's out there. The thing that's really kind of gating things is, from a lot of business perspective, it's still in the early stages of what can we do with this. And, so there's a lot of experimentation going on. The killer app has not appeared yet that says, okay, this stuff's going to blow up. But when you look at everything, it does point to, again, it's what I said before, it's not an if, it's a when.
Well,
but
to build on that, I think we're going to see the current pandemic informing the direction of where voice technology is applied in the next 12 to 18 months. One good example, and I'll ask Simon to share this link I just put in private chat, just on CNBC, I'm looking at the date, just on the 12th, just 2 days ago, on mainstream television, there was a scenario laid out where, as we continue to go shopping and retail shopping, in the colder months, you're not going to be waiting in line to get into the store. In the scenario laid out in this article, they talk about sending push notifications that enable kind of a deli counter kind of interaction, where when you arrive at the store, you may or may not be able to go in right away. There may be a queue. In the cold months, you don't want to wait outside. You want to wait in your car. And so you would get a push notification on your phone that would be, say, the Walmart speaker experience, where that would be integrated with your phone, with your car, to inform you, to tell you what the queue time is, what the expected wait time is. So I think we're going to see voice experiences in novel ways that we haven't seen before, as it begins to address the pandemic and address reducing direct contact with surfaces, as well as encouraging social distancing.
That's I think social distancing and working from home is going to be the new normal now. Adding to it, we do have voice technology coming to self-driving cars. I mean, we have seen in Tesla, you just give a voice command, hey, take me to the home, and the car will drive and take you to maybe a workplace or to your home. One last question that I keep on saying it's the last question, but it keeps on coming. Sandeep, go ahead and ask for an opinion from both of you. Is that, will there be a time when these three big companies like Amazon, Google, or Apple will share the matrices on how they work and how close they are with any of the intent that you provide?
So, so as far as sharing metrics, this is one of those things where right now it just doesn't happen. You have companies like ours that write, that effectively write platforms where we're getting everything coming through the same, since it's coming through the same platform, we've effectively normalized those metrics. The real question, I think, and John, maybe you can speak more to this, is like with that seems to me to be one of the things that they're trying to get to with the open voice network, is a standardization, but I don't know how far, where I don't know where that's sitting on the priority list for them.
Well, one common question that we've gotten from customers is when considering the rollout of a skill, one customer asked us, could you give us a breakdown by zip code what the adoption rate is of smart speakers? And I can't. Alexa and Google does not release that kind of demographic information. They keep that very close to the vest. The best answer for adoption rates for the number of devices throughout a country or a region is voicebot.ai. They do a good job of aggregating the adoption rates of these speakers, the use and demographics of these speakers, and they give a good breakdown of how people tend to interact. What percentage of people tend to use them for timers, for music, for third-party applications, etc. So the answer to that question, I think, right now, today, is go to voicebot.ai. And as for when Alexa or Google would release their own adoption rates and more fine-grained detail information, I have no idea, and I wouldn't hold my breath.
I think that's well answered. I think we have reached the time now, I think, right? John and Sanjeev, you may have some other work too, but I still see many people have joined us. They're still joining us. New people keep on joining, so that I think indeed this session is really, really amazing. The moment this Q&A started, there's a great spike of people joining us for the Q&A. So of course it was a really interesting session. Anything last words or tips that you both guys want to give to the developers coming from any of the background, and if they want to move into this field? Any pro tip, because you guys have been working on this for a pretty long time? What are the tips that you would like to give for people who want to move into this voice technology? Anyone from you can start.
Sanj, you want to take that one?
Yeah. Honestly, it's one of the things I've always found. Just I've been developing software for, as I said at the beginning, like 25, 30 years. Just go do it. All this stuff, like doing an Alexa skill, there are plenty of tutorials on how to do this. Amazon has a lot of nice libraries that make it very easy to just stand something up with Node.js. And again, with Google, there's plenty of examples on how to do this. It's, you don't even have to have an Alexa device to, or a Google Assistant device, because they have test harnesses. So you can actually just go ahead, stand something up, and start playing or poking around with it. It's very, very, it's literally just go to the site and get started. It's just like any other type of technology.
But I would add to that and say, make sure you have when you're developing a voice app, make sure you have a goal in mind. Everybody learns differently, and what seems to work for me when I'm trying to pick up a new programming language is to set a goal, decide what skill, what experience you want to produce, and let that inform and drive what you develop and the skill that you build. And as for, I do see the question on having just completed a bachelor's, how do you get into the field of voice technology? Well, I would say yes, release a sample skill that is a bit more feature rich, does something that somebody else hasn't done yet, ideally. Make it multimodal, make it also interact with the Echo Show, show off. And use that as a calling card for for applying to companies that are using voice technology, specializing in voice technology. Let that be your a shining mark on your resume.
The Sanjeev, you would like to add something? Okay, you're done. Okay,
Yeah,
done, right?
I gave my 2 cents.
Okay, I think I've also shared a link that an article that John wrote on C Sharp Corner sometime back on how you can use Alexa without having an Echo device. So that is an article that John wrote, and I've shared that in the comment section. That was a really great session, Sanjeev and John. A lot to be taken away from just around 60 to 70 minutes. We really enjoyed it, and on behalf of entire C Sharp Corner community and its millions of users, I would like to thank you for your valuable time and your contributions towards the community. Thank you so much once again, and we would love to have you back on our show.
Yeah, it was our pleasure. I
Yeah.
can talk about this stuff at length, and you can find me online at John I73 on Twitter. And of course, I've written a few articles on CSharpCorner, and you can find me there too.
Thanks, Simon.
Perfect.
We really appreciate you having us on.
Bye-bye. Take care.
Take care.